Very good afternoon to everyone. My name is Bhargav HK, Program Lead Bytes. I would like to welcome today's expert, Veniha Kallam. I welcome all the participants to Bytes Expert Series. Today's topic is Java Introduction and Features. I would like to introduce today's expert, Veniha Kallam, madam. Veniha Kallam joined Persistent in 2020 as a software engineer. She is responsible for backend development of cybersecurity platform project, which focuses on compliance, vulnerability, and patch management of endpoints. Once again, I welcome Veniha Kallam, madam. Now I request Veniha Kallam, madam, to continue the session. Madam, for your information, 45 minutes for lecturing, 50 minutes for questions and answers. Please continue the session, madam.
Okay, sure. Thank you for your introduction. So, hello everyone. Good afternoon. Once again, I'd like to introduce myself. I'm Veniha, and I have been working on Java from the past 3-4 years. So today, I'd like to take you through the introduction of Java and its features. And before starting the session, I would like to inform everyone that this is going to be an interactive session. So please, if you guys have any questions or anything, please feel free to ask me anytime. And so before starting the session, I would like to ask anyone if you have any idea what is programming. Yeah, you
Kindly
can.
post your answers in chat window.
Yes.
I have disabled everyone, madam.
Okay. Yeah. Please post your questions on the chat.
Okay, okay.
Okay. So programming means we are creating a set of instructions that tells a computer how to perform any task. So like, for example, we can't just give the computer like add these two numbers 2 and 4 and give me the result. The computer can't understand the direct human language. So we are taking the help of a programming language and making it compiling it to a bytecode or any machine language so that the machine can understand that set of instructions. So today I'll walk you through the Java programming language introduction, its features, the current trends, 2023 Java trends, and its future scope and its career prospects. Yeah. So Java language. Java is a widely used programming language for coding web applications or enterprise level applications. So it has been popular choice among developers for over 2 decades with millions of Java applications still in use today. And you can say at this time, almost 95% of the applications available in market today have any part of Java development in them. So Java programming language was originally developed by Sun Microsystems, which was initiated by James Gosling in 1991, which was later acquired by Oracle Corporation. And the first version of Java was released in 1995 as a core component of Sun Microsystems Java platform, Java 1.0 J2SE, Java Standard Edition. It is a free open source software under general public license. So it is available for everyone free of cost. It can be downloadable and used by any of them. And Java is an object-oriented language, simple, portable, platform independent, robust, secure, and has high performance. So I want to mention this platform independent. That means once we write a Java language in any type of platform, it can be used through multiple platforms. And the latest release of Java is Java 21, and the latest stable release is Java 17. And the mostly, I think, in present market, mostly all the applications use Java 8 because it has the highest features and it's the most stable release. But the later releases like Java 9, 11, and 17 also has some notable improvements. And I'll take you through some of the popular products which are developed using Java. First one is NASA Whirlwind. NASA Whirlwind belongs to the type of geographic information systems where used for satellite maps and all. In that Whirlwind, the program is mostly written in Java and runs through all operating systems. And next one is Google and Android OS. As many of you know, Google uses Java for many of its products, mainly backend programming, but also for user interface development. For example, Google Docs, if you know, which is similar to Microsoft Word. Google Docs is developed mostly using Java. And Android OS. This is Android OS is itself originates from Java Virtual Machine. That means Android OS runs on JVM. So therefore, this language can be used for developing mobile applications. And Netflix, I think this is a most popular entertainment platform which many of you have idea on. This Netflix platform also uses Java for its backend and most of its applications, along with Python. Android and Android TV applications are mostly entirely built on Java with a slight mixture of C++ or C. Spotify is one of the most popular audio streaming platforms, which also uses Java for developing their web applications for smartphones and many other smart devices, as well as for car media systems. So basically, Spotify uses Java and Python to implement some of functionality of its web applications. For example, to log or stabilize some data transfers. And of course, like I mentioned above for Android, so Java is main technology for Spotify application on Android OS. And next is LinkedIn. So LinkedIn today is one of the largest social networks for searching and establishing business connects and jobs. So Java is the main language of the server side of the platform. It mainly implements the logging functionality and tracking. And Uber also uses Java technology with the Python, Node.js, and Go. So according to the developers, they are using Java because of its high performance, which is one of the main characteristics of this language. Java also has the benefit of open source ecosystems and integrates with high technologies such as Hadoop and other analytical tools. So, and of course, these analytical tools, as presented earlier, Uber use Java as the main language in the development of its mobile application for the Android operating system. Amazon, many of you know Amazon as a e-commerce platform, but Amazon is also recognized as one of the largest technology companies in the world, along with Google, Amazon, Apple, and Facebook. However, as far as they are offering e-commerce platform, and also in addition, they are offering development and delivery of cloud solutions such as AWS. So mostly Amazon uses Java for its AWS services. They also prefer to write automation scripts in Java as they are well supported in all of the platforms. And lastly, Minecraft. This is a gaming application which by default comes with the Java version of 1.8. So these are all the main products, popular products which are developed using Java, many of you are aware of. Now I'll take you through the Java architecture. So Java architecture is collection of components like Java Development Kit, Java Runtime Environment, and Java Virtual Machine. So this architecture explains how each and every program is compiled and executed. This architecture has the following steps. The Java is a process. First, it will process the compile and interpretation of the Java code which we have written, and the Java compiler converts the Java code to a bytecode, from where the bytecode is converted to a machine understandable code by the Java virtual machine. and then the machine code will be executed by the operating system or whichever machine we are using. So first will be the Java Development Kit. It is a software development environment used in the development of Java applications and applets. Applets are small Java programs which can be implemented in HTML also. And Java Development Kit JDK holds a JRE, Java Runtime Environment, a compiler, an interpreter or loader, and several development tools in it. So this is a physically existing component where it will internally contains the runtime environment, the compilers, interpreters, and all. And JRE, Java Runtime Environment, is a part of Java Development Kit. It is also a freely available software distribution which has Java class library, specific tools, and standalone JVM. And JRE loads classes, verify access to memory, and retrieves the system resources. Java has an instance of JVM with its library classes and development tools. So Java runtime environment it is mainly consists of the components where we can deploy the technologies such as the deployment of the Java web plugins or Java web starts. And it also has user interface toolkits including AWT, Swing, Java 2D, Access Image, IO. And it also has the libraries which I mentioned. They have integration libraries such as Java database connectivities or Java naming directory interfaces or some more libraries, which are all used for connecting to many different applications or other platforms. And some other base libraries which can support input type, output extensions, Beans, Java management, or Java native interface. So all of these, whichever libraries, some external libraries are all present in the Java runtime environment. And lastly, the Java virtual machine. Java virtual machine can be also called as JVM, is an abstract machine. It is a specification that provides runtime environment in which Java bytecode can be executed. So the previous JRE will run interpret the Java code which we have written and create a bytecode, and this JVM will run the bytecode and execute the bytecode and convert it to machine code and then give the desired output. So JVMs are available for many hardware and software platforms. JVM is platform dependent. So once we run the JRE and create the bytecode, that bytecode can be run through all the platforms which has its specific JVM installed. JVM performs the following operation. It loads the code, verifies the code, executes code, and provides runtime environment. That means once we give the bytecode, it will load it, it will verify if the code is executable or not, and then executes the code, and then provides the environment to execute and return the result of the code. So the main feature of Java is write once and run anywhere. So JVM executes that Java feature. This feature states that once we can write our code and use it anywhere or in any other operating systems also. Besides Java, we have some other languages which uses JVM to run its programs or scripts, such as Scala, Kotlin, Groovy, or Clojure. So all of these Scala, Kotlin, all these use JVM to run its programming language in all the platforms. And I'll show you some of the main features of Java. Java is platform independent. So once the compiler converts the source code to bytecode, Then the JVM can execute the bytecode generated by the compiler in throughout all the platforms like Windows, Linux, Mac OS, Mac, Mac OS and all. Which means if we compile a program on Windows and want to run it on OS, on Linux or MacBook, we can run it with the different JVMs. But it will always produce the same output. And also we have the object-oriented programming. Java is an object-oriented programming language. That means organizing the program in terms of a collection of objects is always a way of object-oriented programming. Each of which represents an instance of a class. That means once Java programming will create a class which will contain a set of objects, or it can contain methods or variables. And we have four main concepts of object-oriented programming, which are abstraction. Abstraction means only exposing high level of public methods for accessing an object. That means, for example, if we have a car, it has so many components like engine, brakes, and blinkers and all. But we are only exposing some of the parts outside the car, like blinker and all. We are not exposing the internal functionality of the car. So that is called abstraction. And next is encapsulation. That means containing information in an object and exposing only selected information. So if we take the same car example, if we want to run a car, we just need to know how we need to move the steering wheel, how we need to use accelerator, clutch, or brake. We don't need to know how the engine works, which principle it works using. So that is called encapsulation. That means exposing only some of the selected information to run the program. And inheritance. Child class inherits the data and behaviors from the parent class. And polymorphism. Many methods can do the same task, like method overriding, overloading. So these are the four main concepts of object-oriented programming. And Java is a simple language. Java is one of the most simple languages as it does not have complex features like pointers or operator overloading like we have in C, multiple inheritances, and explicit memory location. And Java is also robust. Java language is robust, which means reliable. It is developed in such a way that it puts a lot of effort into checking errors as early as possible. That is why we have a Java compiler, which is able to detect even those errors that are not easy to detect by another programming language directly on while compiling the program. The main feature of Java that makes it robust are garbage collection, exception handling, and memory allocation. So Java has a garbage collection facility where once the program ends, it will automatically, once a method or any program ends, it will automatically clear the variables which are used, which will open up more space for us to work on. And Java is a secure language. In Java, we don't have pointers. So we don't have a condition where we can get array out of bound exceptions. And even if we try to do, we have exceptional handling. So that is why several security flaws can be corrected directly while programming. And Java is a distributed language. We can create distributed applications using the Java programming language. Like once we remote method invocation and enterprise Java beans are used for creating distributed applications in Java. The Java programs can be easily distributed in one or more systems that are connected to each other through an internet connection. So next is multi-threading. This is the main feature which has great advantage in Java. Multi-threading in Java supports multi-threading. It is a Java feature that allows concurrent execution of two or more parts of program for maximum utilization of CPU. So that means we can execute multiple programs parallelly. We can create multiple threads and each thread executes without interruption. And portable. As we know, Java code written on one machine can be run on another machine. The platform independent feature of Java, in which its platform independent bytecode can be taken to any other platform for execution, makes Java portable. Next is high performance. Java architecture is defined in such a way that it reduces overhead during the runtime. And at sometimes Java uses just-in-time compiler, which means the compiler compiles the code which is on demand or the highest priority or whichever code is most probably used, so that it makes the application execute faster. Dynamic flexibility. Java, being completely object oriented, gives us the flexibility to add classes, new methods to existing classes, or even create new subclasses through the subclass methods. So Java even supports functions written in other languages such as C, C++, which are referred to as native methods. And sandbox execution. Java program runs in a separate space like JVM, which does not execute in the operating system. It executes in the JVM that allows user to execute their applications without affecting the underlying system, which with the help of bytecode verifier. So this provides security as its role is to check the code if there is any violation of access. And write once, run anywhere, as this is mentioned so many times. Java application generates a .class file after compiling, where we can take the .class file and execute through any of the platforms, multiple platforms where the JVM is installed. It provides ease of architecture neutral, as bytecode is not dependent on any machine architecture. It is the primary reason why Java is used in many of the enterprise applications globally. Power of compilation and interpretation. Most languages are designed with the purpose of either they compile the language or they interpret the language. But Java integrates both the power of compilation and interpretation, as the Java compiler compiles the source code to the bytecode and JVM execute the bytecode to a machine OS dependable executable code. So these are the main primary features of Java. And next, I'll take you through some of the Java trends in 2023. Although Java has been around the past quarter of the century, there are new Java development trends emerging every day. These are some of the current trends that you need to keep an eye on. First is big data. Backend engineers are well acquainted with the concept of data management. But big data requires some attention, as big data refers to large and complex data sets, and we need maintaining these large data sets. So for maintaining these large complex data sets, data engineers must use a high performing language. So, and we have only few programming languages that can handle the burnt of its weight, such as Java and Python. So for big data, Java is a highly recommended technology. And Java technologies and tools like Apache Hadoop, Apache Mahout, or Deep Learning 4J suggest that Java is a prime contender for any big data project that might arise. And we also have remote access solution. With the COVID-19 pandemic drastically shifting how and where workers get their work done, there is no better time than present to make use of Java. Given Java's security features and its unique backend capabilities, enterprise scale solutions using Java are very well received. And building a desktop application providing remote access solutions for work from home users is a great way to use Java technology. The main example is AWS solutions like AWS virtual machines, which we can use, and serverless architecture. So serverless architecture or serverless computing describes an application that runs without you having to manage the infrastructure of a physical server. That means, for example, cloud technology, where we don't need to maintain the complete infrastructure of a operating system. We just need to have a virtual machine to run our programs. So Java is a prime technology where we can use it to develop these serverless architectures. And we also have numerous tools which are available for cloud development in Java, including Oracle Java Cloud Services, AWS SDK, AWS Development Kits for Java, and Google App Engine. And Spring Framework. This is a lightweight, easy to develop Java technology, and it is very popular for web developments, web app developments. And this using the Spring Framework, we can create many web applications where we can for backend development mostly. And next is AI. I think this is the current buzzing trend of 2023. AI-driven applications earn their applause for the sheer potential of technology. So artificial intelligence allows business to scale by utilizing clever algorithms and nifty algorithms. And due to Java's low maintenance and high portability, AI app development with this language is popular choice among all of the developers. And mobile or Android development. Java has been a mainstream Android development technology for many years. But for instance, mobile app developers can now use Java to build applications for wearables such as smartwatches and fitness trackers. So mobile development is continuously seeing growth and new technologies or new ways to use Java. And we can use Java technologies like JUnit, robust framework, Selenium, REST assuring for integration testing in mobile app development. Last but not least, we have Java 9 to 17. That means we have Java version 9 to 17. Java 8 is a major release which is used by many developers currently, because Java 8 has added so many features like Lambda expressions, stream APIs, functional interfaces, where we have seen a major leap in the technology or ease of use we can see in Java. But the later releases 9 to 9, 11, and 17 also has significant new additions such as Jigsaw reactive streams along with API improvements can be seen in the latest releases. So these are the latest Java trends for 2023. And for the career prospects, what Java can be used in or what development can be used in Java. So first we have web app development. Because Java is a free to use and a versatile language, it builds localized and distributed software. And that's why Java is used for developing web applications, including e-commerce sites, social media platforms, and enterprise level systems. Java framework such as Spring, Hibernate, JPA, all of these are used popular choices for building web applications. Next is mobile application development. As you see in Android, Java is the main component while developing Android. So Java is a language of choice for building Android applications which are used by billions of people worldwide. And Java is also used in the development of cross-platform mobile applications such as PhoneGap, Xamarin, etc. And enterprise application development. Java is commonly used in developing large-scale enterprise applications such as banking and finance systems, healthcare, cybersecurity, supply chain management systems. We have so many Java frameworks such as Java Server Faces (JSF), Java Persistence API (JPA), and Java Messaging Services (JMS), which are popular choices for developing enterprise applications. And cloud computing. Java is often referred to as write once, run anywhere, makes it perfect for decentralized cloud-based applications. So cloud providers choose Java language to run programs on wide range of underlying platforms. Next is big data. Like I mentioned before, Java is used for data processing of huge formats of data, and we can work with complex data sets and massive amounts of real-time data and big data using Java. And artificial intelligence. Java is a powerhouse of machine learning libraries. So it has the stability and speed to make it perfect for artificial intelligence development, like natural language processing, NLP, and deep learning. We have many Java frameworks available, such as Apache Spark, Deep Learning 4J, and H2O.ai, which are popular choices for developing artificial intelligence and machine learning applications. Next is Internet of Things. Java is increasingly being used in the development of IoT applications, which require lightweight and scalable software solutions. So Java frameworks such as Eclipse, IoT, ThingRocks are popular developing choices for IoT applications. Next is Java is also used to program sensors and hardware and edge devices that can connect independently to the internet, like smartwatches and fitness trackers. And game development. Many popular mobile or computer video games are built on Java. Even modern games that integrate advanced technologies like machine learning or virtual reality are built with Java technology. Java is used in the development of desktop and mobile applications with popular game engines such as Minecraft and JMonkey engine using Java as its primary programming language. So these are the current trends and features of Java. I'm sharing some of the free tutorials you can access. I have used these tutorials only while getting started with Java, and some of the free programming Java problem solving platforms like HackerRank, CodeChef. All these are open source platforms only, which are free. And you also have, I think, every month we have some coding challenges also, where you guys can participate. And yeah, I'll also share my experience using Java. I also learned Java in my BTech computer sciences. And after joining the company, before joining the company, I don't have much knowledge, in-depth knowledge on Java. I only have some problem solving skills and all. But once I joined, Java is like you need to evolve continuously. You need to continue learning new features. Then you need to keep track on the latest releases, and also see how we can solve one particular problem in multiple different ways. And you need to see the easiest way to solve. So once we keep trying all those things, we can evolve in our problem solving skills. So I think, yeah, that's it for today's session. I'll open the forum for your questions. Let me see.
Dear participants, any queries for Veniha Kallam, madam?
Is Java faster than Python? So running Java applications is faster than Python because Java is already compiled and it only needs JVM to run. It is definitely faster than Python. But developing the Python projects or Python applications is faster as we don't need external access libraries and all. Hope this clarifies your question.
Dear participants, any queries for madam?
Please tell in context of machine learning. Yeah, machine learning also we have so many latest Java is releasing so many libraries like deep learning 4J and many libraries where we can use those libraries for implementing the machine learning platforms. Okay, Java and Python. Yeah, both Java and Python has many libraries which can be used for machine learning, but it depends on which application you want to create. Then we can decide if which is faster. But for creating a cloud-based application or any server-side applications, I think Java is recommended because it can also integrate multiple different programming languages also.